All right, good afternoon, everyone, or good morning. Hope you had a good day. All right, so my name is Shoal. We'll look at the benefits for when using Revit for HVAC design in this webinar. All right, so as we know, we're going to just introduce the topic. We're also going to look at what tools we could use for the specific task, Revit industry-based tools. We'll talk about linking architectural models and outputting again to the industry. We'll look at the energy models and heating and cooling loads and how it changing things will impact our design. Then we'll look at designing the MEP systems and what's involved, and then we'll conclude the session. All right, so the first up, Revit has many benefits, and as we know, Revit has a parametric database background. So when you do any changes in the model, it just updates everywhere. But that's one of the benefits. We'll look at many others throughout the session. All right, and specifically also to the HVAC industry. All right, so as I mentioned, first up, the Revit is a BIM authoring tool, which means that its benefit is that you use it in an environment with other consultants, other architects, engineers, and structural and civil users, and you share your information with them. Now we'll talk a little bit later on sharing and receiving and information from architects, etc. But just on the basics of Revit, Revit, if you change something in plan, it updates all over the show, meaning that if you do an adjustment in plan or section or elevation, it then updates all the other views because it's inherently a database product. And obviously those changes, be it links and number of items, also gets adjusted in the bill of materials. So it's just a more intelligent way of working. Now also the tools that you use we'll discuss as well, but Revit has obviously initially right at the beginning started with just for the architects and then obviously branched out to specific MEP as well as structural based tools. All right, these particular tools allow you to place the objects that you are using, meaning that if you want to place a duct or a duct run or mechanical equipment or a diffuser or air terminal, you would select it off the menu and you would place it in your model. Those components that you place, you can see on the screenshot there of the ribbon or the toolbar. Those components have their own metadata, meaning their own properties. So if you place an air terminal, it might have flow. A duct might have certain material assignments. When you draw it from left to right, it'll have a length. Obviously width and height and everything is included in there. So you're not only drawing lines representing a certain component. As you see in the other screenshot there, those blue lines are actually a duct. But in other programs like AutoCAD or whatever, if you draw a couple of lines that would represent something, a double line could be a wall or a pipe or a duct. Here you actually go and draw a duct, and that duct has a certain length and width and even if it creates it in a system environment and it's got mechanical equipment that drives air within that duct, it will also have flow and various other parameters built in. Right, so that's a benefit of Revit for the HVAC environment, is the object that you place are actually the correct objects that you place. Right, and it has many benefits down the line, meaning that the lengths of each of these ducts can be quantified. The objects that you place, be it a mechanical equipment or air handling unit, that can be scheduled and quantified and costed. Right. Then just talking about that, these real life objects, as you place them from a click and place workflow, once you place them, they are part of this database, and with a click of a button, you can get all the lengths of the ducts, or all the how many air handling units or equipment you have in your project. And obviously, if you delete one of them or you change something in plan, elevation, or section, it just updates these kind of bill of materials or the costing little schedules. So they are live, and you don't have to kind of update them and that sort of thing. It's just the costing just kind of updates. You can also add extra columns here. If I think of the mechanical equipment schedule on the right there, there's the top one, there's a rooftop centrifugal fan. You can add there's just one of them, but you can add an additional column C, and just get a value and then times that value by the count, so that you can do calculations, so that you can create costing. So there's now a second rooftop fan, then that column C will update with double the amount of value or cost. Right, so this is where the efficiency comes in. Yes, you can draw components and items and that sort of thing, but the scheduling and the content that you create gets the benefit. There's lots of benefits down the line. Right, then looking at the another benefit of creating these components, and especially in 3D, is that as you create them, you assign a height to these components. Each of these components have a height, which means that you can, a benefit is that you can check clashes and see, in 3D where these pipes, ducts, etc. run. And you can very easily determine if there's clashes. There is also an automatic, visually, you can determine that. You can also automatically, within Revit, there's a reference or a tool that allows you to test and check clashes between, say, walls and ducts, and it'll highlight those where it finds a clash, right? And that you can then solve before going on site, and obviously that's an awesome benefit. Right, there's also extra tools. It's now not Revit based, but Navisworks, that allow you to configure various models, be it the architect, the engineer, etc., and then do different clash based tools. But obviously the discussion is just for Revit at this point. Right, so a very good means of this 3D is the visualization of it, meaning that if you look at 2D plans, it's difficult to visualize what's happening, and just by quickly spinning the model around, the 3D visualization serves its purpose. Right, then linking with an architect and engineers and other consultants, maybe manufacturers down the line, This is just, the topic here is just linking architectural models, but the idea is also to, exporting it to manufacturers. We'll chat about that, but just in the beginning, when you start a kind of a Revit project with your HVAC cap on, you'll get information from someone, hopefully, if it's available. And normally, your bigger project, you'll get it using from a Revit model. The architects having Revit in the BIM environment, and the benefit there is that you don't have to redraw much. Basically, you don't have to clean it up. It just comes in. It comes in. If you look at the pictures on the that little screenshot on the left, it comes in as a solid. But just by switching the environment from an architectural environment within Revit to a MEP environment, all the walls and the architectural components then become grayed out and see through, revealing obviously your services. So you don't have to clean up much. The components and the walls and the ceilings, everything is there. They just kind of in brackets are half-toned or see-through, and that's just one setting that you change. All right. Another benefit is that because this is in a 3D environment, if the architect then changes anything, heights, walls, ceiling levels, it will then update on your side, and you can do your alterations based on the changes that the architect has done. This process or workflow can be manually done, meaning you pick up the phone and you ask the architect what he has changed. It can also be automatically done, meaning that you can monitor his levels or heights, so that if he changes anything, the software actually flags what has been changed, and then you have the ability to then accept those changes or investigate them, seeing what impact it has on your costing, etc. And then you'll obviously pick up the phone and ask reasonings and that sort of thing. Right, but that's one of the benefits. If the architect, if you're working on a project and maybe there's an architect that uses, just maybe AutoCAD or some other application that's just 2D, you can also import those 2D views and just simply as a 2D view, meaning that if you work in plan, you import his plan. If you work in elevation or section, you import his section or elevation, and then you just draw your ducts floating. That's one workflow. The other workflow is to actually redraw walls, floors, and ceilings as a HVAC engineer. So you redraw the context that you're going to design your HVAC in. The benefit of that is that you would then be able to create spaces and add energy information to those spaces so that you can do a little bit of analysis later on. Or obviously, if you just import the AutoCAD files from the architect, there's no kind of walls that a space can live in, so it might be a little bit difficult. Right, but the best option here is working with an architect that also has Revit that you can just link in his model. Right. Also, if you down the line, if you do work with manufacturers, once you have designed your HVAC systems and components, you do have the ability to export it to a CAD a fabrication products. Those fabrication products could unfold your ducts and nest them in metal sheets to find costing with regards to how it's manufactured, and that sort of thing. That is, I other programs called the manufacturing or fabrication suite. Right, it consists of 3 products. One is drawing that actually links with Revit. The other is estimating, and then there's also kind of another product in there, CAD MEP. Right, okay, so that's linking with other consultants and stakeholders. Normally upfront you'll kind of link with an architect. If not, then you have the ability to draw your own kind of architectural components just to provide context for your designs. All right. I did allude to some of the energy that information that you can add. Right, now just the idea behind it is if you've got obviously walls and a space that you need to provide HVAC for, that space has certain criteria, meaning it's got a type, it's got a construction type. Your building has certain orientation. It has a number of people and the usage of that or the occupancy of that particular space. It's got some electrical load, so if there's machinery or computers or whatever in that particular space, all of these factors contribute to the heating and cooling load of that particular space. And this you can set up for the building or for a particular space, because in a building you might have spaces that are more dense occupied than others or used, and they need more air conditioning than other spaces. Right, so within this environment you would add all these factors, construction, the orientation of the building, the position in the world, and what's handy then is built into Revit is a heating and cooling loads calculator. So it takes all these factors in consideration and provides a report on the loads needed, or the liters per second. Obviously it provides a report on the loads of each space, but then also it provides a estimate on how much liters per second cool air or hot air it needs to cater for or to combat these loads. And that you would then use to add your diffusers in and create a system to cater for these loads. Right, so it's kind of a bottom-up design where each room has its own loads, and then you count them all up to define your air handling units, particular flow and liters per second that it needs to produce. All right. Okay, so there's other things involved here as well, where you've got a product called Insight, which it's a different discussion again, but it allows you to optimize your building. It's more kind of an architectural idea. You can optimize your building to reduce the required HVAC needed to cater for or to serve the building. Meaning that if you change the construction of your glazing or your insulation in the roof, it might impact positively your HVAC design, and that's called Insight. It comes free with the Revit inside the AEC collection, and you can use that to reduce the impact or the size of your HVAC design and that sort of thing. Right, obviously all of this then reduces the running costs of the building, but we'll discuss that in a minute. Right, just with regards to the systems that you can design within Revit, there are many different types of systems. Basically, HVAC, electrical, piping, plumbing, and and there's, you know, the networking, you know, there's alarm systems. Now, a lot of these systems allow you to quantify them, obviously, as I discussed earlier, but also to check and test these systems, meaning if you're doing an electrical circuit, obviously that's not the discussion, but say electrical, you know, DB board, placing the components and tying them together in a circuit. If it isn't a closed circuit, then it would flag you saying that there's a problem. Now, same with the you know, HVAC systems. You kind of create your ducts and all the fittings and whatever involved, and you can very quickly go and test that system to see if there are any gaps or openings so that where air could escape. There's also different type of you know, with different pumping and water systems in pipes. There is a closed loop you know, analysis, but that is also a different discussion with regards to the piping and water and closed loop hydraulic calculations. With regards to the HVAC and the air flow, there are, you know, various tests that you can run within the system, and it shows disconnects and various other items. Just on the little image there, on the right hand side, you do see a system browser. Now, what that system browser is and allows you is to, when you have kind of an HVAC system or a duct run that's kind of fed by an air handling unit, it becomes either a return or a supply or exhaust S, you know, or something different system. But if it is not attached to a system, it becomes an unassigned object. Now, which means that it's costed and counted and whatever, but it isn't part of, say, a duct run. And that's obviously a problem. And you need to then, you know, kind of make sure that all the unassigned objects that are floating or not kind of part of your project or systems are then assigned to a system. Once that's done, if you look at the little image there, and I'll point it out, there's an area there that's called unassigned. If that is 0, you know that all your components, your HVAC components or MEP components are assigned to a system. They are costed and they kind of relevant. Otherwise, they're just kind of floating and it's not actually you know, relevant. Now, again, there are different workflows within Revit MEP, meaning that you can simply just use it to draw. You don't have to do all the analysis up front with regards to the loads and the within each space. Obviously, there is plenty of benefits to that, because then you can specifically just design the system and not over-design it within the Revit environment. Right, so carrying on, you know, that's basically the idea behind your Revit MEP. It's got adequate tools to define the parameters within each space, and then you design your HVAC systems to cater for those loads, right? And that obviously enables you to not under-design or over-design your HVAC systems, because you have catered for the usage of each room, and you know, that impacts the running costs again. So you know, if you over-design your system, obviously it costs more, and you know, the running costs of the building and the building life cycle will increase. So using all the tools within, you know, and Revit, you know, and the benefits thereof, you can really save on the running costs of that building. And that's typically how you would also sell your your knowledge to the end user is that you say that you're going to save this end user with or the building owner some running costs using the tools that are available effectively. Right, and I think that's a main benefit, or one of the premier benefits, is energy efficiency, and that everybody's out to obviously save money and save the planet and that sort of thing. All right. Okay, so if there's any questions, I have the chat box open, so you're welcome to ask anything if you like, and if so, we can deal with it. If it's a little bit, then I can take it offline. All right. Okay, so I just want to thank everyone for attending, and hopefully we'll see you on the next one. All right. Thank you. I'm going to stop the recording, but I will keep the chat box open.